Hello and good afternoon friends, welcome to the CEC-UGC live lecture. Dear friends, with our ongoing series on computer networks and graphs, today we would be talking on functions of TCP, and for this very discussion we have once again with us in our studios Dr. D.K. Lobial. Dr. D.K. Lobial is a professor in School of Computer and System Sciences, JNU. So let's welcome our guest Dr. D.K. Lobial and let's try to grab maximum knowledge through him. Hello sir, welcome to the DataSet lecture.
Till now we have studied about the different layers, and that is the data link layer, physical layer as well as network layer. Now the next layer we studied in the previous lecture is about transport layer, and the transport layer and its functions and how transport layer works. So if you look from that angle, then OSI model had its own transport layer and TCP IP model has its own transport layer. But TCP IP model being one of the most useful model, that is, it is being used on our internet. So what kind of protocols it uses and how these protocols function at transport layer are important to discuss. So therefore in this lecture we will be covering the two protocols which are used in TCP IP model at the transport layer of TCP IP, and how the connection oriented or the reliable protocol, which is most important protocol used in most of the communication in internet, will be discussed. So the 2 days we will talk about the transport layer protocols in TCP IP, and then format of that TCP protocol, and then how it works. This will be the our discussion will be around all three topics, subtopics. Now the transport layer in TCP IP model uses two protocols. One is called user datagram protocol, other is called transmission control protocol TCP. Now these two protocols, before we go in the how these two protocols work, look at this. In the previous lecture we said the transport layer entity from host 1 will communicate with transport layer entity on host 2. Now that means from the application layer on host 1, the data is coming to the transport layer entity, and then that is transmitting to network layer. That means, and then it will make a transmission layer PDU, protocol denied. Now here at this transport entity or at this transport layer, there are two possible protocols in case of TCP IP. One is UDP, other is the TCP. Now at a given point of time when an application is running, it can either use UDP or it can use TCP. So both cannot be used simultaneously by an application. So if UDP is running on host 1 at transport entity, it will communicate with the UDP on host 2 on transport entity. Similarly, the TCP of transport entity on host 1 will communicate with the TCP of transport entity on host 2. So it is a TCP to TCP. That means how the TCP functions, how it combines its data with the control information will only be understood by the TCP on the receiving host. So therefore either it is a TCP communication or it is UDP communication. So that means a process on host 1 which is communicating through a TCP connection will communicate with the TCP on the host 2, which will be used by the process 2 there. So therefore it is a process to process communication. Now having said this, let us quickly go through the UDP where we are not focusing much on that, which is called a user datagram protocol. This is it is datagram protocol. Now this is a datagram service between processes, and you know well what datagram service mean. That means simply the way you deliver a envelope on the post office, you go to the mailbox or the box, you put your letter, and without putting address of the destination on the letter, by the post office mechanism the letter is delivered to the destination, and you do not know which route this has followed and how it goes and how many days it will take, and you do not have any information. So that means what we are saying is the UDP does not establish any connection, does not decide a route or a path before transmission of data. The moment the data comes, it will start sending. That means the UDP on the transport layer of host 1 will simply transmit data to the network layer, and the network layer will to the data, and then the physical layer, and then it will travel through a medium and go to host 2, and then host 2 from physical to data link to network, and then network to UDP or the internal layer to UDP, and then UDP there will unfold the protocol. That means it will remove the control information from the UDP protocol, and then data will be there and manipulate the control information. Accordingly, it will give the data to the application layer on host 2. Now, the question is, the host 1 which delivered data using UDP does not know whether the data has reached at the destination or not. So, it delivered, and it whether reached or not, it has no, therefore, there is no reliability provided whether the data has reached or not. So, that means host 1 or a user will keep on delivering its data using UDP protocol and without knowing whether it is reached or not. That means we do not have an acknowledgement, as well as we do not have what you call is the information whether it has reached there or not. So, that is what the connection less or no connection, and there was no connection overhead because we did not establish any connection. Therefore, it did not consume any time in establishing of a connection. So, one of the advantage of this is that you do not spend time or waste time on establishment of a connection. Now, why it is important that I will discuss, but the another thing, if you look at the header of this UDP protocol and whatever amount of data that will be put after the header. So, these 4 blocks here are only header information or the control information. That is source port, then there is the destination port, you have a UDP length and UDP checksum. What does these field mean? Now, there are 32 bits, and out of these 32 bits, 16 bits are used for source port, 16 bits are used for destination port, and then in the next 16 bits are used as UDP length, next 16 bits are used as checksum bits. That means total 64 bits. There are 4 fields, each of 16 bits, there are 64 bits, and remaining will be followed by the data unit, whatever data you want to put in. So, what does source port mean? That means when a process starts communicating with the transport layer, say with the UDP protocol at the transport layer, that means it will have a socket interface, and the socket interface will identify a process. That means to which process, which socket is connected through a port address. So, that means there are multiple ports on a system on which a process will be connected with a transport layer protocol. So, that each process which is communicating through host 1, because host 1 may have multiple applications or the processes running over transport layer or over UDP. So, if P1 is using UDP on host 1, P2 may also be using UDP protocol on host 1. So, therefore, they will establish a link with the UDP protocol through a port number, which will be a 16-bit number. Then the maximum 2 raised power 16 ports are possible, and out of that earlier 1000 previous first 1000 ports are reserved ports that we will talk about. Similarly, the process running on the destination, say my destination in the previous diagram was host 2. On host 2, the destination process will receive data from the UDP on host 2 through a port, unique port to that host. So, that means the port number on host 2 and the port number on host 1 may be same or may be different, but to a process running on host 1, the port number will be unique. If a host 1 has 10 processes running, then each process will have a unique port. And similarly, if 20 processes are running on host 2, then each process on host 2 will have a unique address on host 2. So, then UDP length, protocol length. Now, the question is how long the UDP datagram size is. So, therefore, UDP length, that is how much data you will have, what is the control information, that length has to be put in this field of 16 bits. So, that means to maximum data could be 2 raised power 16 bits, that is 64K around. The maximum size of a UDP datagram can be 2 raised power 16 bits or 64 kilobits, and if you convert into bytes, divide by 8. So, this is what the size of data if you remove these control fields, which is 64 bit, and there is nothing else, only data, then 2 raised power 16 minus 64 will give you the data, maximum data you can carry with the UDP protocol, datagram protocol. And that is why the ports are the identification of the endpoints. That means, if you look at this, what I am saying is a UDP on host 1 from port number say 1020 is communicating with a UDP on host 2 say port number 1021 or port number 10,000. So, that means a UDP to UDP communication is a port to port communication. If you look at that, means a port on host 1 is communicating with the port so and so port on host 2, right. Now, but the question may arise, why do we need this kind of protocol where we do not have reliability and we do not have acknowledgement? That is what the most important is. When we need, we assume that UDP datagram uses the best effort delivery system. That means, whatever you send, a best effort will be made by the system to deliver the message. That means, mostly it will be delivered by making a best effort. So, the situations where the applications are running, where the timely delivery of information is more important than the reliability of the information. That means, the timely arrival of data is important, then even if it has a low quality or some data missing. If I see a picture which I have to see a live telecast of something which is going on, I have to see it, watch it live telecast, then it is important that I must receive it timely and watch it. Otherwise, even if few frames of a picture are missed in between, the quality of picture may be little bit marginally distorted, which may not be visible by human eyes, because we are not at sharp even if few frames are missed until a major difference is there. So, that will not matter, but the timely delivery of the information, because I am watching a live telecast of something, is most important. So, in that case UDP, without wasting time on connection establishment, without wasting time on transmission of acknowledgement, without wasting time on establishment of a connection, I will immediately start and the live telecast will be done and is useful. But when we need a reliable services, it may not be useful. Then that means what? When you are transferring a file, then even if file takes half an hour to be transmitted or even 1 hour to be transmitted or 2 hours to be transmitted, but I must get the complete file. It should not be that okay, some pages or some portion of the data in the middle of the file is missing. I will not like that, then the information may not be useful for me. Rather than I need a complete information, even if it is delivered half an hour late or 1 hour late. So, that will be fine for me. So, the file will be executed later on. So, this depends on the kind of services where UDP and TCP will be used. UDP is used for unreliable, where the reliability is not important, but timely transmission is important. I will be using UDP protocols. Now, few characteristics of the UDP is it supports broadcasting and supports multicasting. That means, when you are transmitting data, host 1 may be simultaneously send a UDP packet to multiple hosts, say 10 hosts. That is called multicast. Or the UDP may transmit the same packet to all the hosts which are connected to, that is broadcast. So, with the UDP that is possible, and it is packet oriented. That means, I will send a full packet from one end to other end without dividing it to any bitwise. I will send a packet at one go. It is simple protocol because you do not need to establish connection, you do not need to bother about when the connection is lost what will happen, if the acknowledgement is not coming, then how to take care of that. So, all these complications is not required to be dealt in UDP, therefore, it is simple. It is unreliable, but simple. It is a packet oriented, supports broadcasting and multicasting. But the question arises now, it may arise in anybody's mind as a undergraduate student, that IP or the internet protocol which is running below UDP is also a datagram service based model. That means, an IP datagram is being delivered from host 1 to to host 2. So, IP is a datagram based service. Now, if the datagram from here to here, host 1 to host 2 is delivered by IP, then why do I need UDP above IP? That may be a question. Now, the question is, the fundamental difference is that IP datagram or the internet protocol at the internal layer in TCP is also a connectionless service. That means, it will make its own datagram and send from one host to another host. That means, the IP address of host 1 is the important portion here. It is delivering from one IP address to the another IP address. That means, the IP address of the host 1 is a source address, the IP address of host 2 is a destination address. That means, it has delivered this datagram from this host to the another host. Now, how do you determine from which process on host 1 it is coming and to which process on host 2 it is to be delivered? So, now therefore, what we need is, we need the identification of a process which are participating in communication. So, that means transport layer comes in picture. Now, since transport layer comes in picture, so I may be using a transport layer protocol. Now, whether I prefer to use reliable services or unreliable, that is what I told. What is the difference in which situation reliability is not important. So, if reliability is not important, therefore, I will use a UDP protocol above the IP protocol. Now, let us go to the TCP or transport layer or transmission control protocol. TCP stands for transmission control protocol. It is a reliable data. It performs reliable data transfer. That means, from host 1 to host 2, data will be reliably transferred. It has a flow control mechanism built into this, that if the sender sends with a large chunk of data, much more data than the receiver can accommodate, then what to happen? And then it also provides a congestion control or congestion avoidance mechanism, that if the congestion occurs, data loss may take place. So, how to deal with that? And therefore, the occurrence of the congestion must be avoided. So, that is where the TCP becomes important. So, when the reliability is important, that means packet loss should be avoided if it is happening because of congestion or because of any reason. So, probably we need to retransmit the same data again and then wait for the acknowledgement, and when it comes, we are find that my data has reached at the destination, then in a sequence I keep on sending. So, reliability is important. In that case, rather than using UDP over the IP datagram, I may be using TCP. That means what? A TCP protocol will make a TPDU, transport layer protocol data unit, and then that is with all information will go to IP. IP will make a datagram that is containing this TPDU inside it, it will transmit. So, IP is using a best effort delivery service from this host 1 to host 2, but the further reliability information is contained in the TDP. Then that means, when on the host 2, when TCP data unit goes up to the transport layer or TCP, then it will open the control information and then see it has to transmit the acknowledgement and whether the data has come to in the order or not. If it has not come to the order, whether it can put it on the order or not, that has to be checked by it. Now, the TCP service model, if you look at it, it is a point-to-point service. That means, there is one sender, which is a process, there is one receiver, which is another process on host 2. So, that means, from a port or from a process, it delivers to another process. So, it is called point-to-point service. Then it is reliable in order byte stream service. It sends few bytes of data, may not be packet or which we call a segment. So, it sends few bytes of data. So, it is a byte rather than packet service, we call a byte service. How many bytes, that will be talked later on, how the bytes are decided. So, it does not use any packet boundary, it does not use any message boundary. So, it does not say that okay, this is start of a message or a packet, this is end of this. It simply says okay, it goes so many number of bytes, these all bytes may belong to the same packet, they may belong to the same message, and so on and so forth. It is pipeline and flow control. That means, the segments or the data bytes go one by one. in a pipeline mechanism, and its flow is controlled. How? Because the window size set up by the TCP congestion and flow control algorithm. That means, the flow control has an algorithm based on which data transfer will take place. That means, how many bytes of data has to be transferred in one go. That means, when TCP is transmitting, how many bytes it will put in the TCP format or the TCP segment. It will determine that, and based on that it will send it. And how it will determine? It will determine based on the window size. The window size is, meaning by here is that how much data the receiver's buffer can accommodate. It must have that information. So, therefore, it will be able to control the flow, and it will send one by one. That is what the pipeline mean now. So, this is a connection oriented service. So, the connection is established based on handshaking. That is what we call initial state. In the initial state, handshaking will take place, and then it is called a three-way handshake. I will explain what does it mean little later. And then it is a full duplex data transmission. That means, at the same time, data can be transmitted in both the directions simultaneously. If host 1 is transmitting data to host 2 at the same time simultaneously will be transmitting data to host 1. So, it is both way communication simultaneously. That means, it must use two channels at one go. Now, look at this, what does it mean now? The TCP sender has a buffer and TCP receiver also has a buffer. So, the application writes data on the TCP socket. If it is a socket is a data structure which will be associated with a TCP protocol through a port and will taking data from the application. So, application will write data on the socket buffer, and from socket buffer there is a data structure, and the transport layer will take the data and put that data into the TCP segment. And then this TCP segment is transmitted from this buffer. TCP sends buffer, whatever in data it sends, and that we call a segment, and this segment goes to the host 2 where this will be accommodated in the buffer of this TCP, and from there the application and this TCP will transmit it to the socket buffer. From socket buffer the data is taken by the application layer, so on and so forth. Now, what does three-way handshake mean now? TCP protocol, it establishes a connection through three-way handshake, though I will explain through a diagram later on. But what does three-way handshake means? That means, assume when I am shaking my hand with some other person, I may put my hand forward, that is I initiate handshaking, and another person may extend his hand or her hand to shake, that is response from the person, but I may withdraw my hand now or I may shake, I have both the choices. So, that means, when I initiate, that I am asking the other person whether he or she agreed to shake hand or not. When she or he extends hand, that means she or he agrees to handshake, but now I may not agree or I may agree. My initiating handshake does not mean I have an agreement, because my agreement will also depend on the after the other person acknowledges that the handshake will take place. So, then if I say yes, then I will extend and will shake the hand. That is called a three-way handshake. And then otherwise, if I withdraw, then it is only otherwise if I say put my hand and shake, and that is two-way handshake. So, this is TCP connection established by three-way handshake. Okay, now we talked about three-way handshake, that to set up a connection. Now, another characteristic of a TCP protocol is that every byte has its own 32-bit sequence number. That means, when you are sending bytes in a TCP protocol, that means every segment will have a 32-bit sequence number. So, that if a segment is transmitted and if they do not arrive in the order, looking at the sequence number, the destination TCP can put them in order. That is what, and these 32-bit sequence number, it wraps around. That means, then how many sequence numbers are possible? That means we have 2 raised to the power 32 sequence numbers are possible. That means if each segment has one sequence number, so for transmitting data, I can, if I am sending a large amount of data, that means the large amount of data can be divided into how many segments? 2 raised to power 32 segments, that is 4 GB. That is 2 raised to power 32 segments can be made out of a given data if the data is used. Then what will happen afterward? If all has been completed, that means if you have sent 2 raised to power 32 segments, then still you have data pending for a single message I am talking about. That means you have a big message of say some GB of 10 GB data, and if I make small segments of 1 byte, 2 byte, then I can have 2 raised to power 32 segments will exhaust very quickly. Then I have more data to send. That means then the number will wrap around. That means it will begin from the again from the sequence number 0. From 0 up to 2 raised to power 32 minus 1, then again it will come back to 0. So that will wrap around. And this there will be a 32-bit acknowledgement as well, and the window size in bytes. That means how much is the size of the buffer is equally important. So that is window size means the size of the buffer available. It is also gives the information that if the window size is 4, that means there is a 4 byte, or in terms of 32 bits it can tell. But ACK acknowledgement number is in terms of 32 bits. That means if it is acknowledgement for one, acknowledgement for the second segment, and for acknowledgement for which segment. So each acknowledgement should also have a number that is also 32-bit number. Segment is your unit of data that is being exchanged, and that will have what? Therefore, a segment is a 20 byte header plus optional field in the header plus data, right? And then there is a limit for size of a TCP segment. What is the size of the TCP segment? It is 64 kilobyte, right? The limit for the size is 64 kilobyte, and then MTU agreed upon for is what is maximum transferable unit is agreed that not more than this much data can be transmitted in each direction. That means the sender and the receiver has to make an agreement that how much data can be transmitted. I said that depend on the size of the availability of the buffer of the receiver as well. If the based on that, they will agree that only this much data can be sent in one segment. So that is what MTU is. Then data from consecutive writes may be accumulated in a single segment. When the data is written from the application layer or a process to the sockets or to the transport layer, then multiple data because one write, another write. If you look from the operating system point of view, the write operation, read operation, when the data is being written into the buffer of the TCP, then one segment may consist of more than 1 or 2 writes consecutive. And the fragmentation is possible. If a segment is big, it can be fragmented into small. Then the TCP protocol also uses sliding window. We have talked about the stop and wait and sliding window protocol in case of while we were discussing data link layer. Then and that is its same protocol sliding window can be used at TCP by the TCP as well. Now look at this format of the transport TCP protocol format. Now this is the 32-bit from here from left to right, and there are how many fields if you look at. There is a source port, there is a destination port, then followed by sequence number, followed by acknowledgement number. And if you look at the source port has to be 32-bit as we talked about in 16-bit as we talked in case of UDP. Similarly, the destination port is also. Then you have a sequence number, then you have acknowledgement number, then you have TCP headers, length, header length, then you have 6 flags, and in between there is a gap, that means it is unused. Then you have window size, you have a checksum field, you have urgent pointer, then options. Option field is a 32 bit 0 to 32 bit. Then the optional field is data, how much data you want to put in that. But the size limit is 64K. If you recall, it is a 64 kilobyte, you cannot have more than 64 kilobyte. That means 32 bit means 4 bytes. Now, let me explain that what does each field mean now. Source and destination port, and each is a 16 bit, as we talked in case of UDP, same is in case of TCP. Now, sequence number is a 32 bit. Each segment has a unique sequence number, and then the consecutive segments will have successive sequence numbers, and even if they do not go in the order, then they will be put in the order by the destination. Then acknowledgement number, when the receiver is sending acknowledgement, each acknowledgement has to have a number, and it is also a 32 bit number. Otherwise, how does the source will know that it is acknowledgement for the segment 1 or it is acknowledgement for the segment 2. Now, if you look at, you may say that why the sequence number and acknowledgement number are in the same TCP packet. The reason is, if host 1 is sending data to host 2 and host 2 is also sending data to host 1 simultaneously, but at the same time, when a segment 1 from host 1 arrives at host 2, now host 2 has to transmit an acknowledgement for segment 1, and host 2, assume that, has to also send a segment 2 data to host 1. So, host 2 is doing two activities. One, it is sending acknowledgement for host 1. Second, it has to send data to host 1. Now, it has two choices. It should send acknowledgement first, then data segment, or it should send data segments on, then send acknowledgement. Second is, it should combine both and send at one segment, right. And then if it is available simultaneously, data is available and the acknowledgement has to be sent, for the sake of minimizing communication overheads, that means consumption of bandwidth and decreasing delay, it is much better to combine both together in one data segment or one data segment and transmit it. That is what you call piggybacking, we have been talking about. So, piggybacking is useful here. So, that means the same TCP segment is carrying the data as well as carrying the acknowledgement. Therefore, the acknowledgement number field exists here. Now, the next field is your header length, TCP header length, and TCP header length is 4 bit in 32 bit words. What does it mean? That means 4 bit. That means if you have to specify length, you can say length is 0, 32 bit word, length is 1 32 bit word, length is 3, up to how much? 15, because 4 bit means 2 raised power 4, 2 raised power 4 means 16, and 16 means 0 to 15. So, the header length can be 0, header length can be 1, header length can be 2, header length can be 3, 4, 5 up to 15. At a time only one value. Say header length is 8. What does 8 means? 8 means there are 8 32 bit words. If I say there is a first word consists of 32 bit, next word consists of 32 bits, another next word consists of 32 bits. If I have such 8 words, that means how many bits? 32 into 8 bits, right. That will be how much? 2 raised power 5 into 2 raised power 3, that is 2 raised power 8, which is equivalent to 2 raised power 256. That means my header length, in that case the header length is 256 bits, which is 4 32 bit words. That is what we are talking about. 128, 32 into 4 is 128 maybe. Now, sorry, 8 into 256, correct. Now, that means 8, I said 8, that is 4 bit. Now, so header length is talked in terms of how many 32 bit words are there. Next field is flag, if you look at, and that flag, because this in between this shaded area is unused area. Now, there are 6 flags because each represents 1 bit, URG 1 bit, ACK 1 bit, PSH 1 bit, RST 1 bit, SYN 1 bit, FIN 1 bit. So, that means there are 6 bits, and these 6 bits are called flags. What does it mean now? That means there are 6 flags, each consists of 1 bit, and I will explain these flags later on. But then after that there is a window size, and window size is a 16-bit number of bytes. How many bytes? 16-bit means the window size could be, maximum size of a window could be 2 raised power 16. 2 raised power 16 is 64 kilo, or you can say 65305, something like that. So 65,365, that could be the maximum length of a window size. If I say window size is 20, that means there are 20 bytes. That means the receiver can accommodate only 20 bytes. So a window size, if it can be 2 raised power 16, that means it can, the receiver's buffer can accommodate 2 raised power 16 bytes. So this is the information. So while this negotiation is going on, it can tell about how many bytes it can accommodate. Then that means sender is allowed to send starting at byte acknowledge. So from where it should send these many bytes. Then there is a checksum field now. What does this checksum field mean now? Checksum field is a 16-bit field, and it is done for error checking. That means whether the TCP segment received by the receiver is having error or not having error. So this checksum field, there are 16 bits put in this field, and that bits are checked by the receiver and see whether the segment has error or not. How it is done? Now look at this. If you apply a function on your TCP data or header, and this function will take the header data and then say it gives some output, and that output you save in the checksum field. When the TCP arrives at the receiving end, again the header data is taken, the same function is applied, it gives some output O2, and the output O1 which the sender computed I have saved in checksum field. If O1 equal to O2, then there is no error in the segment. If they do not match, then the segment has an error. So this is for error checking. If the segment has an error, that means the communication is not reliable, it must be retransmitted. That means acknowledgement, negative acknowledgement should come. It says that the packet or the segment which I have received is not correct, it is erroneous, therefore it will send acknowledgement, negative acknowledgement, and the sender will retransmit it. Then the most important is the urgent pointer. Now you may say, what does urgent pointer mean now? This urgent pointer is a 16-bit field. It tells about the byte position of the urgent data. That means I may tell that the data from this byte in a segment, you say data from this position, first byte, second byte, third, fourth, if a data is 10 byte data, so first byte, second byte, byte position 4, that means from 4th byte, the remaining data is urgent data up to 10 byte, up to the end. What that urgent data means? That means this data has to be sent urgently, it may not wait for much, and it will send out of band. Even if no channel is available, it must be given preference so that it reaches urgently. That is, suppose you are establishing a login through telnet, and when you try to log in, and this login information has to be immediately delivered to the destination. So this should be treated as urgent. The segment, the TCP segment carrying the login information for the telnet should be treated urgent. It may be sent out of band by delaying everything else. So that is what the urgent data mean. Now look at the 6 flags we talked about. The 6 flags we talked about is in this figure. Said URG, that is called urgent pointer. Then you have ACK, PSH, RST, SYN, and FIN. What each flag mean now? This each flag mean here now. URG, it refers to the use of urgent pointer. If the flag value is 1, that means the segment contains an urgent data. So if there is urgent data, it should be delivered urgently. If this is 0, that means there is no urgent data in this. Then ACK, because if this flag is 1, that means there is ACK also contained in the data segment, acknowledgement is also contained. If this field is 0, that means there is no acknowledgement contained in the data, because sometimes while transmitting, because first time when a host transmits data to another host, it may not have to send any, has to send an acknowledgement, because it has not received anything from the another one, because it is a initial stage. So, it may say that the ACK value is 0, therefore, no acknowledgement, only data is being transmitted. Then the third flag is PSH, that is push, the meaning is push. The receiver should deliver data without delay to the user. That means, if it is 1, that means it is urgent, and when it is received by the transport layer or the TCP on the transport layer, it should immediately deliver it to the application layer. That is what push means. Then RST, that is reset the connection. Sometimes the connection may be dropped, it has to be reset. So, if this, so that means when the connection is lost, disconnected, it has to be re-established. Then the sender has to send a data segment or a segment requesting for re-establishment of a connection, or requesting for a reconnection or reset the connection. This connection is not working properly, reset it. So, if this bit is 1 and the receiver will know it is a reset connection information, I have to reset the connection, not it is sending any data or so and so forth. Then sync, when used when establishing connection. When host 1 is sending a data segment to establish a connection with host 2. So, this is initially the sync bit is set 1 when it is a data segment is sent to request to the receiver to establish a connection. So, it is a connection establishment initial request is called a sync packet or sync segment, in which the value of sync flag is 1, and finish FIN when the connection has to be closed. If the fin, that means when the client or a host 1 requests the server or host 2 for close of a connection, it is sending a request. Sending a request means it will send a special segment, and in which the value of the fin flag will be 1. So, as soon as it is received by the receiver, it will look in this field and say that okay, the value of fin field is 1, therefore, it is a request for connection closure, and then it will accept it and respond accordingly. So, there are 6 fields, they have a different function to perform. Now, another field is an option field. What does it mean? The option field is used maximum payload a host is willing to receive, right? And then we can say that how much data it will receive, willing to receive, we can tell from the window size, but at the same time it may scale the window factor and use selective repeat instead of go back n. Now, let me, what does go back n means? Whether it is using, generally it will use sliding window and with selective reject, but I want to say that no, it should not use selective reject, it should use go back n. So, I will give this field in the option field, and that is the maximum payload a host is willing to receive may not be exact multiple of the address length size or the packet size in terms of bytes. So, we have to feed some data. So, the padding has to be done, right. Now, how does TCP connection is managed? So, this is one is that you have to establish a connection, you have to release a connection, 2 phases now. In connection establishment, we do 3-way handshake and then a connection identification now. 3-way handshake, as I said in the beginning, that means when 3-way handshake is being done, that means the host 1, if it is willing to establish connection with the host 2, I am referring to the old diagram, then it has to initiate a connection request. That means it will send a TCP segment, a special segment, which talks about establishing a connection. That means the sync value of sync flag is 1, and it will say what is my initial sequence number I will use. It will put that information in the at the initial sequence number. It is clock based, means depending on the time, a initial sequence number will be generated. So, it will put that sequence number in the segment, and no reboot after crash, that is maximum packet time is 120 seconds it uses. That means if already 120 seconds has been expired, after crash you do not need to reboot, otherwise reboot, that is what it is, wrap around, and it has to 3-way handshake after how many segments the wrap around will take place. And that I said in a 3-way handshake, it sends its initial sequence number, and okay, I will explain a little later, but let me put first what connection, and then connection identification means the source when it is requesting, it is also sending the port ID of its own endpoint, and when it goes on the receiver side, it will send acknowledgement and send its own port number and its initial acknowledgement number and the sequence number, so on and so forth. That means, and the window size. The initial parameters are being negotiated while 3-way handshake is taking place. So that means host 1 requested say, okay, this is my initial sequence number and this is my buffer size, it sends to host 2. Host 2 will say, yes, I agree, this will be my initial sequence number, this is the acknowledgement number I will begin with, this is the buffer size available with me, and I will use this port number as well. When this information is received by the host 1 may not agree with the what information host 2 has sent. So therefore, it is only 2-way rejected, that is what 3-way. If it agrees, it says yes, I agree, so 3-way handshake takes place. So in connection identification, they have to find the pair of ports. What is the port number used by the source? What is the port number used by the destination? So they will identify those ports. The important is connection release. The both sides has to agree separately for connection release close. So host 1 has to connection close request. It will go to the host 2, then host 2 will agree and send its connection close request. Both will close separate, and then host 1 will close, host 2 will close. After that, host 1 will close. And if no response to close request comes after 2 into t second, means t is the time taken to one way go, multiplied by 2 means going from host 1 and coming back to host 2. How much time it takes? If I am sending a FIN request, it takes t time to go to the host 2. It does not go there, I will wait for another t time in it. If I do not receive anything, that means I did not receive any response for FIN. Then both sides close, wait for twice of t seconds. If it does not get this response for this period, it will close the connection. Now, this is what 3-way connection management means. What is being done? Host 1 sends sync request with sync sequence number x, then host 2 responds with this. I will send my data with sequence number y and acknowledgement with sequence number x plus 1, and it says sync bit is 1, and then finally connection is established and host 1 sends data with sequence number x plus 1 and acknowledgement for y plus 1, and so on and so forth. And second case, what happens is sync 1, the host 1 sends sequence number x, host 2 say I will send sequence number y, then both keeps on sending data. This is not 3-way handshake, this becomes only 2-way handshake. Now the third is the congestion control, how the congestion is closed. Now control. Now when the packets are lost, right, after a time out period is over, it will wait for certain period of time, either the packet or segment has an error or the router has a congestion. In both the cases, the packets are lost. When the packets are consecutively lost, then we assume that the congestion has occurred at certain routers and therefore packets are not being delivered. Now, so this is an end-to-end control. That means one end is controlling congestion to the other end. That is not, the network layer is not controlling the congestion. That means the 2 ways, how does it do? By limiting the transmission rate, I can control the congestion because my window size is fixed. On over a segment, what is the window size, and by limiting that, my transmission rate with the size of the window over the segment. That means if I have to send a big segment, I will not send, depending on the window size I will make my segment and then transmit at the same rate, therefore no overflow takes place. Now one of the important thing here is, let us look at that, it is being done in 2 phases. First is slow start and then it's congestion avoidance. That is how the TCP works. And the congestion window size is important. Depending on the congestion window size, we will send data, and the other variable is a threshold. 2 important points. I will quickly explain them. Slow start means one segment, a host will start with one segment. If it gets timely response RTT, within RTT period it gets a response, then it will send 2 segments. Then it is also getting response timely, then it will send 4 segments. So it will send then 8 segment, and while it keeps on getting response within the RTT time, that means a round trip time, how much time it takes time data takes to go from host 1 and the response back, that is called RTT. So, if the response is within RTT, I will keep on exponentially doubling the number of segments in each number of segments every time. Now, that means I am starting slowly by one segment. If it is everything is fine, then 2 segment, then 4 segment, then 8 segment, assuming that if there is no congestion, then segment will go timely, 2 segments will go timely, and so on and so forth. If everybody starts with a lot number of segments, then congestion may occur. So, I am slowly starting means I am avoiding congestion, that the congestion will not occur. Now, while this is being done, what happens is, if you look at this graph, you send one segment and you send 2 segments depending on the congestion window size, then you keep on, then 4, then 8, then 16, you reach at 32. What is this diagram? So, at 32 it may have that the data on the network may be more, then I have reached a threshold, my threshold value is 32. Now, I say that if I send 64 now, the congestion may definitely occur. So, therefore, I will start linearly one by one, 32 plus 1, then 1, till I go to the timeout period. That means the congestion may occur, then I may again begin from the beginning and halving the threshold. Now, I will reduce the threshold, assume that the congestion has occurred, timeout period has come, and then I will start from the beginning and I will make this threshold half. That is the way I will go with, right. So, that way the TCP also controls the congestion. So, by this, what we have covered in this lecture is, we talked about the format of the UDP and the TCP, why UDP is important, in which situation UDP protocol has to be used, and in which situation TCP protocol has to be used. We also discussed about the formats of the both and what are the fields in these formats. And finally, we talked about the congestion is not only controlled by the network layer or the IP layer, it can also be controlled by, in a two-phase manner, like by starting slowly and then avoiding the congestion. We can also manage the congestion at the transport layer. Thank you.
Well, thank you, sir. Thank you so very much for your precious inputs to the lecture. And dear friends, your feedback are very, very important for us. Please write to us at info.cc@nic.in. All the lectures pertaining to the series Computer Networks and Graph are already there on YouTube. This lecture for your availability would also be there very soon. So, we would like to tell you all that your feedbacks are important. So, keep writing us and keep watching us. We would be meeting again soon. Till then, take care. Goodbye. Thank you so very much.